Hi, in this video we have another example related to RC circuits. It's a charging process capacitor. I have a battery with a resistor and capacitor connected in series. It's asking me what is the voltage across the capacitor after 2 time constant. What is the voltage across the capacitor after 6 seconds, and when is the current through the resistor uh, be reduced by 25%. Alright, let's start with the first one. When I say what is the voltage across the capacitor after 2 time constant, well, that means I need to find first how much is the first time constant by multiplying the resistor by the capacitor. It's 10 to the power 3 multiplied by the capacitance value 470, 10 to the power minus 6. If you do the math, then that will give us 4.7 seconds. Alright, now the question is asking for how much is the voltage across the capacitor after 2 time constant. Well, you could calculate how much is the second time constant. Simply it's 2 times 4.7, and that will give you 9.4 seconds. Or you can straight away apply that to the voltage formula when T equal to tau equal the voltage across the battery by 1 by exponential raised to the power 2 T over tau. Now here's a trick. I can keep that as 12, the voltage, 1 minus exponential minus T tau divided by tau, or the time constant. So in this equation, I don't really need to calculate what is the value of the first time constant or the second value of the time constant as a value like 4.67 or 9.4 seconds. I could just plot it in the equation, and I will just cancel the time constant with the time constant and just do the math. That will give us so exponential of minus 2, that is 0.135, so it's 1 point minus 1, it's point, so this one will be 12 multiplied by 0.86, and this one gave us 10.32 volts. That's how much voltage across the capacitor after 2 time constant. Okay, now let's try to find how much is the voltage across the capacitor after 6 seconds. Now here we go. Before I start doing the calculation, I can predict my answer where it will be as a voltage. Is it above or below certain values? Now we know from the definition of the first time constant that it is the time when the voltage across the capacitor will be 63% of the total battery voltage. Okay, now my first time constant is 4.7 seconds, and the question asking for 6 seconds, which means the voltage across my capacitor now in 6 seconds should be above this value. So if I want to do quick guess, at 12 multiplied by 0.63, now at first time constant the voltage will be 7.56 volt. Now I am moving beyond that first time constant, so my voltage across the capacitor should be above 7.5, but it's definitely below the value we found on the second time constant, so it will be between the 7.5 and the 10.32. Let's do that the calculation to make things have more sense. Now the second the voltage across the capacitor at 6 seconds will be the voltage of the battery 1 minus exponential T over RC. Okay, Now the voltage across the battery, it's 12. Here 1 minus exponential 6 over 4.7. To do that, okay, I have my 6, okay, exponential, that is 1 minus, that will give me 12 multiplied by 0.72. If I do the calculation for that, 0.72 times 12, that will give me the answer 8.6 volts. And exactly as I expected. I expected the value to be between the voltage at first time constant and the voltage after 2 time constant. And it's 8.6. It's between 7.5 and 10.3 volt. So it's really good to learn how to predict your answer based on your understanding to the graph of charging a capacitor. I could draw that. It might help in some cases. That's the voltage across the capacitor. Normally we said we start from 0 until we reach the maximum. Okay, now the first time constant here, that's tau, it was 4.7, and usually the value across the capacitor is 0.63 of the battery voltage. Now when we had the 2 time constant, the voltage was here, it was 10.3 volt. Now I'm asking you to find how much is the voltage across the capacitor when it was 6 seconds, or somewhere around here. I might change the color. So my value, it is really somewhere in between, and it is this value here. Okay, now for the third question is finding how much is the current through the circuit or through the resistor, when is the current will be reduced through this circuit to be 25%. In this case, he's asking me to find when is the current will be 75% of the total. So this value here now, it is going to be representing 0.75 of the maximum value, because he's telling me when it will be reduced by 25. So I will take 25% from 100%, the maximum. That means I have only 75% left from the total current. Exponential. I could replace that with a 2. Now, the maximum current with the maximum current will cancel each other. I will end with a 0.75 equal, raise the t tau. Now, to do this equation, I should find the len for both sides, and that will give me 0.75 equal minus t over tau. Now, simply just to do the calculation, t will be minus tau then 0.75. Now we know this one, it's 4.7, and the len of 0.75, it is negative 0.288. Minus with minus, that's definitely gonna be positive. The time always gonna be positive, and as an answer, that's giving me 1.335 seconds. That's the time required to drop or to reduce the current through this circuit by 25%, or we can say that's the time needed to keep only 75% of the total current in this circuit. Okay, I hope you find this video useful. Hopefully we'll see you again in another one. Thank you.